Well, hello, my students. This is Mr. Kingsbury. Fabulous to see you here. Today I want to talk about solving rational equations. I have 6 examples I'm going to work through, so it may take a minute. And you can't hear anything. Oh, yeah, you can. Wow. Sorry, I'm trying out a new thing, a new recording setup, and I didn't think that I was recording, but I am. And you can hear me, and I'm wasting your time. So let's try this again. Let's talk about solving rational equations. So this is for Algebra 2. Our current unit is rational functions, and we're solving rational equations today. That's our topic for the day. I am Mr. Kingsbury. Please make sure you put your period and today's date at the top of your notes. I'm assuming you're taking notes. And our question is, how do I do this? How do I solve rational equations? I think it's a great question. I don't have a list of steps for you. I can't say this is what you always do because it really depends on what you're given. What I would remember is our simplifying steps. Remember, we talked about multiplication, division, and then addition, and then subtraction, and how to simplify expressions, rational expressions that have those things in them. So what I would do is when you approach the equation, decide what kind of operation you have going on and how to simplify that side of the equation. And once you've simplified both sides, then you should be left with something that will be much more manageable. Let's just start with an example that I think should be pretty straightforward and uses the easiest operation, multiplication. So let's say we have x minus 4 times x plus 3 over x minus 5 times x minus 4. And we're going to multiply that by 10 times x minus 5 times 2x plus 7. And that is over 2x plus 7. And we're going to set that equal to 5x. And I realize that on the right side over here, there's not even a fraction, really. It's just a number. We're not going to worry about this. This is as simplified as it gets. So we're going to focus on the left side and just simplify all this business. Now, the operation I see is multiplication. And if I remember correctly, we do 3 things to simplify a rational expression that is using multiplication. We factor out the GCFs. We cancel stuff, and then we write what's left. Well, guess what? There are no GCFs, no greatest common factors in any of these, which is great. That's one less thing I have to worry about. So the next thing I can do is start canceling things. And as long as the binomial or term or number or whatever is both on the top and on the bottom, I'm good. So like x minus 4, I can cancel. X minus 5, I can cancel. 2x plus 7, I can cancel. And that looks like about it. So what I have left over is 10 and x plus 3. And I know some of you may be saying, but the x plus 3 came first and then the 10. You're correct. And if you want to put the 10 over to the right, you can. Mathematicians generally prefer to put a single number in front of a binomial as opposed to behind it. And this will equal 5x. Now, I know what I said. I'm going to be a little shifty for a second. I know that I said the third step when you're simplifying rational expressions with multiplication is you write what's left over on top and what's left over on the bottom. Technically, the stuff on the bottom got canceled. These technically all became 1s. That's what really happens here. So there should be a 1 on the bottom. We know that whenever you have a fraction and there's a 1 in the denominator, you don't really have to write it. We can get away with being a little sneaky and not writing it and just writing what's on top. So now I'm going to solve this. And I think the first thing I'm going to need to do, I'm just looking at it, is I've got 10 times x plus 3. I think I'm going to distribute that 10. So I get 10x plus 30, and that's going to equal 5x. Now from here, what I see is that I have a variable on both sides. I only have a constant here. So I'm going to leave this constant on the left and get rid of the 10x. It's a positive 10x. So I'm going to subtract 10x from both sides. On the right side, 5x's minus 10x is negative 5x. On the left side, 10x minus 10x is 0, and 0 plus 30 is 30. So I now have 30 equals negative 5x. Let me say that a different way. This is 30 equals negative 5 times x. So I'm going to now divide both sides by negative 5. On the right, what that does is it gives me a 1. Negative 5 divided by negative 5 is 1. 1 times x is x. That was the whole point of the thing. Get x by itself. Over here, I got 30 divided by negative 5. That's negative 6. That will be my answer. It wasn't the easiest thing in the world to solve, but it wasn't difficult either, especially once we simplified things down. Just a little distributing, adding and dividing, or subtracting and dividing, not a big deal. A lot of these problems are going to be like that, where once you've simplified things down, it becomes much easier to work with. Let's look at another one. We got 3 over x plus 4 plus 1 over x plus 4. And that's going to equal 1 over 4. Now, if I look at the right side, that's simplified. There's nothing to do. There's no operations. So I'm not going to touch the right side. On the left side, though, I could add these. So I'm going to check, since it's addition, I know I need a common denominator. I'm going to check the denominators. They are the same. So I'm going to rewrite this as 1 fraction over x, with x plus 4 as the denominator. And on top, I got 3 plus 1. Still equals 1 over 4. And 3 plus 1 is 4. So this is 4 over x plus 4 equals 1 over 4. And I actually really like this. Whenever I have two fractions equal to each other, we call this a proportion. Oops. And we solve proportions by cross multiplying. And I'm going to suggest that you set things up first before multiplying. So we're going to multiply 4 and 4. So I'm going to set up 4 times 4 equals, and then we're going to multiply 1 and x plus 4. Now my concern is that people are going to go, all right, we're going to go 1 times x plus 4. That is not actually 1 times x plus 4. That's 1 times x plus 4. We need to show that we're multiplying the whole thing, all of x plus 4 by 1. So use parentheses instead as your multiplication symbol, if you will. And that's going to set you up for success there. So let's see here. 4 times 4 on the left is 16. On the right, 1 times x is x. And 1 times 4 is 4. So I have 16 equals x plus 4. Looks like all I need to do is subtract 4 from both sides. On the left, 16 minus 4 is 12. On the right, 4 minus 4 is 0. X plus 0 is x. Looks like I get 12 equals x. There we go. All right, we're 1/3 of the way done, guys. Okay, let's do another example. Example 3. All righty. What if we had x minus 3 times 2x minus 3 over x plus 1 times x plus 9. And we're going to multiply that by x plus 1 times x plus 9 over x minus 3 times 3x plus 5. And we'll set it equal to just 7. Cool. All right, so hopefully I did that right. Yep, I did. Go me. So on the right side, again, just a number, nothing to simplify. On the left side, we've got multiplication going on here, 2 expressions. We need to simplify this. Now with multiplication, I mentioned this on example 1, we do 3 things. We factor out the greatest common factors, then we cancel everything that we can, and then we write what's left. So I don't see any greatest common factors, which is great. None of these seem to have a greatest common factor bigger than 1, which is wonderful. So that means that's one less thing to deal with. Now I can start canceling. So for example, x plus 1 and x plus 1, those cancel. X plus 9 and x plus 9, those cancel. X minus 3 and x minus 3, that cancels. Looks like the only thing left is 2x minus 3 here, 3x plus 5 here. Those don't cancel. So I'm going to write 2x minus 3. And then 3x plus 5. And I'm going to set that equal, wow, I'm having a hard time with my lead today. Set that equal to 7. Now, as I'm looking at this, I'm reminded of example number 2, where we ended up with two fractions equal to each other, and we could just cross multiply. And it occurs to me that if my 7 was a fraction, we could do the same thing here. So instead of writing 7, I'm going to turn that into a fraction and write 7 over 1. Remember, you can change a number, you can change anything into a fraction by putting it over 1. Now that I've done that, I can cross multiply. And again, you're going to want to set it up before you solve it. So we've got 1 times 2x minus 3, and that will equal 7 times 3x plus 5. And then I will distribute my 1. So I get 2x minus 3. And I will distribute my 7. 7 times 3x is 21x. 7 times 5 is 35. And from here, we can start solving. Now, the honest truth is, it does not matter which of these you select to cancel. Pick any which one that you want, cancel it out, you're fine. Fine. After that, though, you will have 3 terms left. And one of those terms will lead you down the fastest way to the solution. The others will have you really just moving things from side to side. Now, I'm not saying that you can't move things from side to side. You can. That's the beautiful thing about mathematics, about arithmetic especially, and algebra. As long as you follow the rules, you can do all kinds of things. The big question, though, is what you're doing getting you closer to the answer? I have a preference where I like to keep my coefficient positive. That's just a thing for me. What I found is sometimes when I do that, I end up saving myself a step because I'll end up canceling out a term with a variable in it, and I'll end up with a coefficient of positive 1, which means I don't have to divide by anything, and that's great. So that's a personal preference, and that's what I'm going to do here. I want you to know, though, you can cancel any of these. What you have to decide then is, what do I cancel next? So for me, I've got two terms with variables, 2x and 21x. 2 is smaller. It's a positive 2x, so I'm going to subtract 2x from both sides. On the left side, 2x minus 2x is 0. 0 minus 3 is negative 3. Apparently, I need to move myself quickly. Let's see. On the right side, 21x minus 2x is 19x, and then we'll add 35. Then we get to the part where we have to be kind of choosy. If you were to cancel the 3, that's not really going to do anything because that'll leave you with the 0 on the left and still 2 terms on the right. Anytime you cancel a term, you want to end up with 1 fewer terms than you started with. We started with 4, for example, here. Now we have 3. Here's my suggestion. Whatever you canceled the first time, cancel the opposite type from the opposite side. Here's what I mean. I canceled something with a variable on the left. Now I need to cancel something without a variable on the right. That will be 35. So I'm going to subtract 35 from both sides. On the left, I get negative 38. On the right, 35 minus 35 is 0. 19x plus 0 is 19x. So I have negative 38 equals 19 times x. And I will divide both sides by 19. On the right, 19 divided by 19 is 1. 1 times x is x. That's getting annoying. And negative 39 divided by 19 is negative 2. So that one took a little bit more time, but still not too bad. Let's see. Unfortunately, I'm running short of time here, so I'm going to probably need to jump to 1 or 2 of these. Let's do this one next. because it's awesome. This one kind of freaks people out. We got x over x plus 4 plus 7 over x plus 4, and that equals x minus 5 over x plus 4. On the right, again, there's not a whole lot to simplify. On the left, I can add those. I do have a common denominator, so this becomes 8 plus 7 over x plus 4, and that will still equal x minus 5 over x plus 4. And this fraction on the right usually freaks people out a little bit. 8 plus 7, by the way, is 15. So this is really 15 over x plus 4, and that will equal x minus 5 over x plus 4. And here's the cool part. Because in this particular instance, both fractions have the same denominator, I don't need to worry about them at all, and I can simply set the numerator so that since the fractions are equal and the denominators are the same, I can assume that the numerators are equal, if you will. So this is really just 15 equals x minus 5, and if I add 5 to both sides, I get that 20 equals x. Awesome. I've got to squeeze one more in here because it's a division one and it's important. And then I'm going to have to let you guys go so I can go teach class. Here we go. We've got 3x minus 2 times x plus 3. And that is over x plus 3. That's going to be divided. We're going to divide that by 3x minus 2 over 4 times x plus 3. And we're going to set that equal to x plus 9. Once again, on the right side, nothing to simplify. On the left side, we've got a division problem, so we need to simplify that. The rules for simplifying a rational expression that's using division, there's 4 of them, right? First, we keep, change, flip. Keep, change, flip. Then we factor the greatest common factor, and then we cancel, and then we write what's left. So let's do that. We're going to keep the first one. 3x minus 2 times x plus 3 over x plus 3. We'll change division to multiplication, and we'll flip this. 4 times x plus 3 over 3x minus 2, like that. Still going to equal x plus 9. Okay? Then we would factor out GCFs, but once again, no GCFs, which is awesome. And then we can cancel stuff. So 3x minus 2 cancels. X plus 3 and x plus 3 cancels, and it looks like what we're left is 4 times x plus 3, and that's going to equal x plus 9. We'll distribute our 4, so we get 4x plus 12. That's going to equal x plus 9. And I'm going to go ahead and subtract the x. You can technically subtract any of these that you want. 4x minus 1x is 3x, still adding 12. On the right side, x minus x is 0. 0 plus 9 is 9. So I canceled a term with a fraction on the right. Now I need to cancel a term without a, I said fraction, I meant variable. I need to cancel one without a variable on the left. That's going to be 12. So I'm going to subtract 12 from both sides. On the right, 9 minus 12 is negative 3. On the left, 12 minus 12 is 0. 3x plus 0 is 3x. So I have 3 times x equals negative 3. I will divide both sides by 3 to undo that multiplication. On the right, negative 3 divided by 3 is negative 1. On the left, 3 divided by 3 is positive 1, and 1 times x is x. That leaves me with the statement x equals negative 1, which is my answer. I apologize that last one was a little fast. I appreciate you guys paying attention. Good luck, and I'll see you in class.